From Cape Canaveral Air Force Station, Florida, United Launch Alliance presents live Atlas V launch coverage. At Space Launch Complex 41, an Atlas V rocket is fueled and ready to launch MUOS-4, the fourth Mobile User Objective System satellite for the United States Navy.
Range, go for launch. Roger, go for launch.
T-minus 3, 2, 1.
Atlas engine ignition.
Liftoff of the United Launch Alliance Delta IV Heavy rocket.
This is Atlas Mission Control at T-minus 30 minutes, 21 seconds and counting. Launch countdown operations are continued, and the team is not working any issues at this time. The window for this morning's launch opened at 5:59 a.m. Eastern Daylight Time and would remain open until 6:43. The launch team was working an issue that caused a delay in fueling, and that issue has been resolved, and we are now targeting a 6:18 a.m. Eastern Time launch for this morning. Good morning, and welcome to Mission Control here at the Atlas Spaceflight Operations Center. I'm Steve Agate. MUOS-4 delivery on orbit is scheduled to take place nearly 3 hours after liftoff, and because of that long duration, we'll conclude our live coverage about 25 minutes after launch. However, before we sign off, I'll be joined by Commander Paul Benishek from the United States Navy Communications Satellite Program Office to discuss MUOS capability. At T-minus 4 minutes, the launch count will enter a planned 8-minute hold. This hold will allow launch conductor Scott Barney and his team time to check final systems and also resolve the outstanding issues prior to entering the terminal count. At this point, however, we remain on schedule for a 6:18 a.m. liftoff. This morning's launch is the latest in a long partnership between the Navy and the Atlas program. For more than 35 years, Atlas has supported the United States Navy, launching 22 missions, including the Fleet Satcom, UHF, and UHF follow-on satellites. Atlas V launched the first MUOS satellite in 2012, followed by MUOS-2 in 2013, and MUOS-3 earlier this year. The MUOS-4 satellite is the latest addition to an advanced network of orbiting satellites and relay ground stations that is revolutionizing secure, tactical UHF communications for mobile military forces. Users with operational MUOS terminals can seamlessly connect around the globe with new smartphone-like capabilities, including simultaneous crystal-clear voice and video and mission data on a high-speed Internet protocol-based system. The MUOS team is led by the Navy's Communications Satellite Program Office. Lockheed Martin is the prime contractor. We recently received a weather briefing from the 45th Space Wing's weather officer. The weather is within the launch commit criteria for this morning's liftoff. The probability of violating launch constraints is 10%, the ground winds are 5 to 7 knots out of the south-southwest, and the temperature 81 degrees Fahrenheit. So after several days of unsettled weather here on Florida's east coast, the forecast has improved, and we are proceeding towards a targeted liftoff with a planned T0 of 6:18 a.m. Eastern Time. There will be a final weather briefing a few minutes from now. ULA is using the Atlas V 551 configuration to launch the MUOS-4 mission. This is the 56th Atlas V Evolved Expendable Launch Vehicle flight since the inaugural launch in August 2002, and the 6th flight of the 551 configuration, the largest in the Atlas fleet. A number of important milestones took place leading up to launch. The Atlas V launch vehicle is produced in Decatur, Alabama, and Harlingen, Texas. It is comprised of a common core booster powered by the NPO Energomatch RD-180 main engine, 5 Aerojet solid rocket boosters, and a Centaur upper stage powered by the Aerojet Rocketdyne RL-10C engine. The MUOS-4 satellite is protected during ascent by the RUAG-built 5-meter diameter payload fairing. On July 24th, final Centaur processing began at the Delta Operations Center using a new process known as off-site vertical integration. The Centaur upper stage and other structural elements were assembled vertically, saving time and mitigates the risk of weather-related delays. On August 10th, the MUOS-4 satellite was encapsulated inside the payload fairing. Also on August 10th, the Centaur and payload adapter stack was transported from the dock to the vertical integration facility at Space Launch Complex 41 and mated to the Atlas V booster. On August 19th, the encapsulated payload fairing was transported to the vertical integration facility, or VIF, and mated to the Atlas V. In preparation for launch, the fully integrated Atlas V on its mobile launch platform is rolled from the VIF to the pad at Space Launch Complex 41. The VIF is located approximately 1/3 of a mile south of the launch pad. Trackmobiles are used to transport the Atlas V and its mobile launch platform to the launch pad, a 1/4-mile trip that takes about 30 minutes to complete. Once the mobile launch platform reaches its park position at the pad, the team conducts final securing. Once the pad has been cleared about 4 hours before launch, the Atlas V is fueled and configured for launch. The Atlas V rocket stands 206 feet tall, or about 21 stories, and weighs nearly 1,300,000 pounds fully fueled. To lift the Atlas V away from the pad, approximately 2.5 million pounds of thrust, produced by the RD-180 engine and 5 solid rocket boosters. This is Atlas Mission Control at T-minus 22 minutes, 48 seconds and counting. We're anticipating a final weather briefing about 1 minute from now.
RC, LC, Net 1.
RC.
Conduct weather briefing on Channel 8 Weather Conference Net.
Roger.
T-minus 20 minutes.
Perform BRC with SIB1 and SIB2 voltage checks.
Roger.
T-minus 19 minutes.
Perform RD-180 transducer converter calibration.
We've just received the final weather briefing. The probability of violating launch constraints is 10%. The ground winds are 6 to 7 knots out of the southwest, and the temperature remains 81 degrees Fahrenheit. Still proceeding for a 6:18 a.m. Eastern Time liftoff. This is Atlas Mission Control at T-minus 18 minutes 6 seconds and counting. At nearly 7.5 tons, MUOS satellites are the heaviest payloads to date to ride into space atop any of ULA's Atlas V launch vehicles. From its vantage point in geosynchronous orbit, MUOS-4 will cover approximately a third of the Earth's surface and uses its 14-meter diameter reflecting mesh antenna to communicate with ground-based users. Let's take a look at a video detailing MUOS-4 trip to orbit. The following profile details the important events of this mission using approximate times.
Go Atlas. Go Centaur.
T-minus 5, 4, 3, 2, well, you have RD-180 ignition and liftoff of the United Launch Alliance Atlas V rocket.
The Atlas RD-180 main engine and 5 solid rocket boosters ignite to lift the vehicle away from the pad. Shortly after liftoff, Atlas begins its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile and minimize aerodynamic loads. The Atlas V reaches Mach 1, the speed of sound, at 36 seconds. At 51 seconds, the vehicle experiences maximum dynamic pressure. The first 2 solid rocket boosters, or SRBs, are jettisoned at 1 minute 46 seconds into the mission, followed a second and a half later by the remaining 3 SRBs. At 3 minutes 22 seconds, the payload fairing is jettisoned. Approaching booster engine cutoff, the Atlas V is burning propellant at the rate of 1,672 pounds per second, traveling at approximately 12,576 miles per hour, and located 84 miles in altitude and 277 miles downrange. Booster engine cutoff occurs 4 minutes 23 seconds after liftoff. 6 seconds later, the booster stage is jettisoned. The first Centaur main engine start takes place 10 seconds after booster separation. Cutoff of the Centaur main engine occurs just over 12 minutes after launch. The mission now enters an 8-minute post-phase. At just over 20 minutes into the flight, the Centaur main engine is restarted. This burn will last nearly 6 minutes. Following the second Centaur main engine cutoff at just over 26 minutes, the mission enters a nearly 2.5-hour coast phase. The Centaur main engine is restarted for a third and final burn at 2 hours 49 minutes. Following a 58-second burn, the Centaur main engine is shut down. At 2 hours and 53 minutes, Centaur releases the MUOS satellite for the United States Navy.
Primary address TechX file. Address underscore Alpha Victor 056 underscore 04 with SDLCRC Bravo 9 Bravo 0 has been received, verified, and is ready to load into the SDNU.
Proceed with load.
This is Atlas Mission Control at T-minus 11 minutes, 57 seconds and counting. We are not working any issues at this time and are still proceeding to a 6:18 a.m. Eastern Time launch.
GC, LC, Net 1.
GC.
Step 830, switch all secondary decoms to RF link.
Roger.
This is Atlas Mission Control. Now at T-minus 10 minutes and counting. We're not working any issues at this time and are still proceeding to a 6:18 a.m. launch.
Bravo 9, Bravo 0 has been verified and loaded into the FPNU.
Roger. Atlas Propulsion LC Net 1.
Go ahead.
Yes, status is step 850.
Stand by. It's still in work.
Roger.
T-minus 8 minutes.
This is Atlas Mission Control at T-minus 7 minutes, 11 seconds and counting. We're not working any issues at this time and are still proceeding to a 6:18 a.m. launch. Today's mission is dedicated to ULA employees Jimmy Johnstone and Guy Harris. As a member of ULA's Decatur team, Jimmy was thrilled by each and every launch and brought a wealth of knowledge and ability accumulated over 25 years with Boeing and ULA. Jimmy always had the ability to look at things from the positive side and was able to brighten the day of all those around him. Jimmy was generous to his family, his friends, and to a multitude of others whose lives he touched, giving of himself and helping others. As a valued co-worker and friend, his loss leaves big shoes to fill. Jimmy will be long remembered and greatly missed. This morning's launch is also dedicated in memory of Decatur production operations co-worker Guy Harris. Guy was a committed and dedicated team member for more than 33 years, beginning his career at Martin Marietta. Guy displayed a wealth of knowledge and professionalism in his role as a quality engineer. He will be remembered as a caring and respectful gentleman who maintained the highest standards of integrity and willingness to assist others. The MUOS-4 mission is a fitting tribute to Guy because he was a true patriot. He honored and respected our nation's military members and took a special interest in his co-workers' family members serving in the United States Navy. Today, Jimmy and Guy's many ULA friends celebrate their lives and wish them Godspeed. Today we also honor Jim Loisel. Just minutes ago, Captain Joseph Kahn from the Navy's PMW 146 delivered this remembrance to the launch team.
The launch of MUOS-4 is dedicated in memory of Captain Jim Loisel, United States Navy, retired. Jim executed the MUOS program in its formative years with pride and precision, and left his indelible mark on PEO space systems, the Navy, the nation, and the warfighters we serve. As the fourth MUOS satellite is launched and becomes operational, the vision he began over a decade ago is now a reality. Thank you, Jim.
RFFTS LCNet 1.
Sir, go ahead.
Establish Davis system cameras configured for launch.
Roger. Davis system cameras configured for launch.
Roger.
T-minus 4 minutes and holding. This is a program 8-minute hold.
CISA purge flowing GN2 to the CISA.
Roger. For all personnel, we are complete through Operation 50, Step 1020.
LC Step 1100, redline monitor and event table are in the correct configuration for terminal count.
Roger.
This is Atlas Mission Control at T-minus 4 minutes and holding. We are not working any issues at this time. This is a built-in hold, and we are still proceeding to a 6:18 a.m. launch.
Attention on the complex. All communications switch to channel 1. All personnel and visitors remain in present position until launch. Maintain operational silence in the LCC.
Terminal count briefing. If a condition exceeds a launch constraint any time after a terminal count status check, the observer shall announce hold, hold, hold on channel 1, identify their station, and briefly state the reason for the hold. MUOS-1, LCNet 1.
OSM.
Looking for
Roger.
MUOS-1.
The launch of MUOS-4.
Ignition SNA switch in the enabled position.
SRB ignition enabled.
OSM verify FCO, RCO, and OSM hold fire switches are in the proceed position.
Ready to proceed.
Perform launch on time verification.
Roger.
RC verify solar radiation acceptable for launch.
Verified.
This is Atlas Mission Control at T-minus 4 minutes and holding. In a few moments, launch conductor Scott Barney will poll the team for the final go to pick up the countdown. 27 engineers and managers will be polled for system status and readiness to proceed with the launch. This is the final status check before launch for all Atlas vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The readiness poll includes hydraulics, paired water deluge system, electrical systems, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as launch conductor Scott Barney performs the final polling of the launch team.
Status check to proceed with terminal count. Respond go, no go. Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
HASGAS.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
Instrumentation.
Go.
COM.
Go.
Timer.
Go.
GCQ.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
ACs go.
Range coordinator.
Clear to proceed.
Launch director.
The launch vehicle is ready to launch.
Mission director.
This is the mission director. You have permission to launch.
Proceeding with the count. T0 is planned for 10:18 Zulu. Set count to start at 10:14 Zulu.
Roger. T0 is set for 1018 Zulu. Count will start at 1014 Zulu.
Polling is complete and the launch team has been given the go for launch. The countdown will resume approximately 2 minutes from now. From T-minus 4 minutes until launch, you'll be listening to launch conductor Scott Barney and his team performing the final steps in the countdown procedure. You'll hear the team call out the Atlas LO2 topping has been secured, followed about a minute later by the call out for transferring the Atlas and Centaur stages from ground facility power to internal battery power. At T-minus 1 minute 55 seconds, the team will command the launch sequencer to start, followed shortly by securing the Centaur LH2 and LO2 topping activity. At T-minus 1 minute 40 seconds, the team will command the flight control system to launch enable and arm the flight termination system. In the final minute, the Atlas tanks will be verified at flight pressures, followed by verification of Centaur tank pressures. A final status check of Atlas, Centaur, and MUOS-4 readiness is conducted at T-minus 25 seconds. Seconds before liftoff, the RD-180 engines ignite and perform a health check, followed by the ignition of the 5 solid rocket boosters to lift the vehicle off the pad. After liftoff, you'll hear the voice of Marty Malinowski providing launch vehicle ascent data.
On my mark, the time will be T-minus 4 minutes and counting. 3, 2, 1, mark. T-minus 4 minutes and counting.
3:55.
This is Atlas Mission Control. The countdown clock has resumed and we are proceeding towards a 6:18 a.m. Eastern Time liftoff.
Three minutes.
Securing LO2 topping.
Atlas change to flight pressure.
250.
FTS internal.
This is Atlas Mission Control at T-minus 2 minutes, 31 seconds and counting. Once the rocket lifts off, it will take only about 34 seconds to reach Mach 1, or the speed of sound.
$159.
Vehicle internal.
Launch sequencer start.
150.
Securing Centaur LH2.
Securing Centaur LO2.
140.
FCS launch enable.
This is Atlas Mission Control at T-minus 1 minute, 32 seconds and counting. The launch vehicle, payload, ground systems, and Eastern Range are still go for launch.
120.
Orca's armed.
FCS count started.
115.
Reduce CCS for launch.
Roger.
110.
Vent valves locked.
T-minus 1 minute and counting.
Status.
Range green.
$40.
Stable at step 3.
T-minus 30 seconds and counting.
ECS reduced for launch.
Roger.
25.
Status check.
Go Atlas.
Go Centaur.
Go MUOS.
15.
This is Atlas Mission Control at T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. RD-180 ignition and liftoff. Liftoff of the United Launch Alliance Atlas V rocket carrying the 4th Mobile User Objective System mission for the United States Navy. MUOS significantly enhances communications for U.S. forces on the move. You're now hearing the voice of Marty Malinowski providing launch vehicle ascent data. Let's listen in for mission progress.
Roll program is complete. SRB chamber pressures have plateaued. Mach 1. And booster has throttled back up right on schedule. Engine response looks good. Pump speeds are good. Injector pressures are as good as well. Max Q. Body rates look good. Engine has now achieved the proper throttle setting. Response looks good. And we have begun to throttle down. Engine response looks good as well. SRB chamber pressures looking good. Looking for burnout momentarily. And we have SRB burnout. And booster has now throttled to maintain a 2.5 G throttle in preparation for payload fairing jettison. Coming up on SRB jettison. And we've jettisoned 1, 2, and all 5 solids. Looks like a good separation. Now flying Q alpha limited steering. Vehicle rates look good. RD-180 continues to perform well. Closed loop steering has been enabled. Body rates continue to look good. Current altitude is 41 miles, downrange distance 58 miles, current velocity 4,992 miles per hour. RD-180 continues to perform well. Pump speeds, injector pressures look good. Body rates controlling right down the middle. Bus and battery voltages are good as well. And the RCS pyro valve has been fired. That system's now pressurizing to flight levels. Signatures look good. Booster continues its throttle to maintain 2.5 Gs in preparation for payload fairing jettison. Current altitude 67 miles, downrange distance 148 miles, current velocity 7,719 miles per hour. And we have payload fairing jettison. Looks like a clean jettison. And we have CFR jettison. Booster has throttled back up. Engine response looks good. All systems are nominal. Coming up on our 4.5 G throttle segment. And now throttling to maintain a 4.5 G throttle. Boost phase chill down is underway. Boost phase cool down is complete. And we have BECO, engine shutdown looks good. And we have retros and stage separation. Looks like a clean step. We have LOX and fuel pre-start on the RL-10. The GN2 purge firing on the RCS is underway. We have ignition and full thrust on the RL-10. Centaur steering has been enabled. Body rates look good. LO2 tank pressures have been vented down as expected. RL-10 performance looks good. PU has gone to closed loop control. Engine response looks good for that. Centaur is currently flying at 120 miles in altitude. Downrange distance is 595 miles. Current velocity is 13,827 miles per hour.
This is Atlas Mission Control at T plus 5 minutes 53 seconds. We've just heard Marty Malinowski confirm successful completion of the early phase of today's mission. All systems continue to operate nominally. The mission is currently in the first of 3 Centaur engine burns. Our next event, Centaur main engine cutoff, will occur in approximately 7 minutes. I'm now joined by Commander Paul Benishek from the Navy's Communications Satellite Program Office. Commander, thanks for joining me.
Thank you, Steve. It's a pleasure to be here.
Commander, what benefits does MUOS bring to the table?
Well, MUOS works like a smartphone network in space, vastly improving secure satellite communications for mobile users and the U.S. forces. MUOS provides users a global, on-demand, beyond line-of-sight capability to transmit and receive high-quality voice and mission data on an Internet Protocol-based system.
We're here for a satellite launch today, but I understand that there's much more to the system.
Absolutely. MUOS is a complex orchestra comprised of a 5-satellite constellation, 4 ground stations across the globe, an integrated waveform, radios, and complex software to manage the network. Additionally, more than 55,000 currently fielded radios and terminals can be upgraded to be MUOS capable, with many requiring just a software upgrade.
Commander, this is a Navy-led program, but only services can use this capability.
That's correct. The U.S. Navy plays a key role in national space efforts by providing narrowband satellite communications for the Department of Defense. While MUOS was designed for mobile users who require worldwide secure voice and mission data at higher data rates, these capabilities are also available for ships, aircraft, and ground vehicles used by all U.S. military services.
Commander, what kind of improvements can warfighters expect to experience?
That's a great question, Steve. So, the MUOS constellation will provide users with 10 times more communications capacity over the legacy system. You see, legacy satellite communication systems allowed users to talk as long as they were within the same satellite footprint. MUOS allows troops all over the world to talk, text, and share mission data seamlessly without having to worry about where they are in relation to a satellite.
Commander Benishek, thanks for all that great information. We'll continue our discussion after the next major milestone.
Engine performance continues to look very good. Chamber pressures, pump discharge, fuel venturi, all within expected regions. Tank pressures are stable. RCS lines continue to warm towards bottle temperatures. This first burn is scheduled for approximately 464 seconds in duration. Range track shows Centaur making good progress right down the corridor. All Centaur systems continue to look very good. RL-10 performance is nominal for the set MR. RCS line temperatures have nearly achieved bottle temperatures. Haulage pressures are stable. Helium bottle pressures look good. Batteries are good. Centaur continues to request an oxidizer-rich condition.
This is Atlas Mission Control at T plus 10 minutes 32 seconds into the MUOS-4 mission. All systems continue to operate as expected. The Atlas Centaur second stage and MUOS-4 satellite are currently located over the Atlantic Ocean, east of Antigua. Our next event, the first Centaur main engine cutoff, or MECO-1, is scheduled to take place in about 2 minutes. Here's Marty Malinowski.
Centaur continues to make good progress down the middle of the range corridor. Current altitude is 138 miles, downrange distance 2,075 miles, current velocity 16,942 miles per hour. Approximately 1 minute to MECO. And we have IIP vanish. Centaur is now orbital. RL-10 continues to perform well. PU controlling near nominal. RCS line temperatures have achieved bottle temperatures. Tank pressures are stable. Batteries look good. And we have MECO. Engine shutdown looks good. We have 4S settling motors on.
This is Atlas Mission Control at T plus 12 minutes 38 seconds into the flight. The MUOS-4 mission is currently in a coast phase over the Atlantic Ocean, traveling in a southeasterly direction over the west coast of Africa. Our next event is the second start of the Centaur RL-10 engine. This event is scheduled to take place in approximately 7 minutes. While we wait, let's take a look at a MUOS video.
MUOS, the Mobile User Objective System, is the U.S. military's answer to secure and reliable tactical communications for the foreseeable future, and it's being delivered by the United States Navy.
Yeah, 3 critical points for the MUOS program is first, it's operational, supporting the warfighter every day. Secondly, it brings enhanced capabilities over the legacy system. And thirdly, it is critical for the tactical warfighter.
MUOS is a global system, and it allows the communicator to make a call from, say, DC to the Middle East, all in one system. That capability is brand new, and with that capability, it brings a lot of opportunity.
Born from the need for stable 24/7 ship-to-shore communication that could be successful regardless of environmental and geographical conditions, the Navy is assigned the responsibility to provide this vast capability known as narrowband satellite communication.
So from a space accomplishment perspective, MUOS-1 was the highlight of our effort at the time. But fast forward to now, with the launch of MUOS-4, we are going to deliver that worldwide coverage and communication service for the users.
The nice thing about MUOS is that the ground system and the terminals contain all the switching and routing technology. The satellite remains unchanged over time, and we can allow technology insertion into the ground and the waveform over time to increase capability without having to make any satellite changes.
The MUOS WCDMA is similar to technology embedded in smartphones all over the world. It brings many benefits and improved capabilities over the legacy SATCOM system. It is already being demonstrated in various environments and for many purposes, like worldwide broadcast, extending SATCOM to individual soldiers, and communications above the Arctic.
The legacy payload we have on the MUOS satellites allow us that smooth transition to a newer, better MUOS capability. We are benefiting from that idea as we are providing the legacy channels for current user, and we are exploring all the capability that MUOS has to offer.
Users with MUOS terminals can seamlessly connect beyond line of sight around the globe. MUOS's new smartphone-like capabilities include simultaneous crystal clear voice and video and mission data on a high-speed internet protocol-based system.
The IP-based nature of MUOS allows network access to unclassified and classified networks. This network access for deployed tactical users will allow the exchange of critical situational awareness and targeting information. As a naval pilot, MUOS will really bring that expanded communications chain, will allow us to coordinate with those forward air controllers, those tactical controllers that need air support at a much greater range. So there'll be less time over the target area. We'll be able to get there, provide the support, and leave.
With that smartphone comes the ability to introduce new applications, new ideas that haven't yet been envisioned by the warfighter. It's exciting to think about over the next 10 years how this system is going to actually be used versus how it was envisioned to be used by the original designers.
More than just satellites, MUOS is a complex DoD orchestra comprised of a 5-satellite constellation, 4 ground stations across the globe, an integrated waveform, the radios, and complex software to manage the network.
The mission of end-to-end integration is to bring together all of the systems that are required to deliver a MUOS capability to the warfighter. The MUOS program office was responsible for building the satellites and the ground systems and the software that programmed them, but other government program offices were responsible for delivering terminals and the teleport to connect MUOS into the global information grid.
MUOS's design allows it to extend UHF communications further north and south on the globe than ever before. This coverage into polar regions of the world is significant, considering wireless and satellite communications have always been a struggle at those latitudes.
For a whole host of reasons, the Arctic is becoming more important. So we'll be able to rely on communications here just like you were anywhere else in the world.
Warfighters need satellite communications on a variety of terminals: small, large, man-portable, and airborne. The key to this terminal implementation is the MUOS waveform.
The government makes that waveform available to any of our U.S. vendors who's building a product intended for use by the military. They take that waveform, they implement it on their product, and we assist them in providing laboratory facilities where they can complete their integration work. And the end result is more MUOS products that can put the desired capability into the hands of the warfighter that's suitable for their mission environment.
MUOS-4 is the fourth in the current constellation, and it will complete our global coverage for MUOS. And so the complete system for us is the 4 WCDMA payloads on orbit, the 4 ground stations, and 2 satellite control facilities. This is going to be really, really important in terms of providing beyond line of sight capability for our users. With MUOS-4 up and operational, we'll close the link and we will have coverage almost pole to pole and around the world.
Assuring current capability, developing next-generation communication technology, launching the future.
That rocket carrying MUOS-4 into space is like a giant flare, signaling to the users in the field that they're about to get an amazing new capability in their hands.
The Navy has and will continue to deliver mobile, tactical satellite communications to the Department of Defense.
Once operational, MUOS-4 will complete the MUOS network's near global coverage, with MUOS-1, MUOS-2, and MUOS-3 satellites already on orbit. MUOS-5, an orbital spare satellite, is expected to launch in 2016.
Centaur LOX pre-start has begun. We have ignition and full thrust on the RL-10.
As Marty Malinowski just reported, the Centaur main engine has been restarted for the second of the 3 Centaur engine burns. This burn will last approximately 6 minutes. The Atlas V continues to travel in a southeasterly direction, following our next event, MECO 2, or cutoff of the Centaur RL-10 engine. The Atlas V will cross over the African continent, continuing in a southeasterly direction over Madagascar, where the trajectory will switch to an easterly heading. Separation of the MUOS-4 satellite will occur over the Indian Ocean, south of Indonesia. As a reminder, separation takes place 2 hours, 53 minutes after liftoff. Our live coverage will end following our next event, MECO 2. Commander Benishek, it's great to have you back. Paul, can you give me a feeling for what kind of system testing has taken place so far?
Of course. So in our testing, we've tried to be as realistic as possible. So in several events, we've actually brought in uniformed warfighters, given them training on the MUOS system, and then allowed them to exercise those operations in a realistic environment, be that in vehicles driving around, in a forest with a thick canopy, or even in airborne platforms as well.
You mentioned previously the joint nature of the program. What work have you done with the other services?
We have great relationships with many of the other services and organizations like the Air Force, the Army, the Coast Guard, and Special Forces. We enjoy a great relationship with the Army as they prepare the Manpack radio for MUOS integration. The Army has been the primary user during our development tests and operational testing from Fort Bragg, Fort Drum, and Fort Lewis. The Navy also works hand in hand with the Air Force. They provide invaluable transport and launch support and have demonstrated MUOS capability using C-17 in-flight mission demonstrations flying high above the Pacific Ocean. Also, Special Ops representatives have been key in helping us evaluate and refine our ConOps. And lastly, I also want to mention the great relationship we're developing with the U.S. Coast Guard. For example, the research icebreaker Healy demonstrated how robust MUOS is as it conducted Arctic research this summer.
It seems like things are changing pretty quickly and all for the better.
Yes, it's a pretty exciting time with that smartphone-like capability because it comes with the ability to introduce new applications and new ideas that haven't yet been envisioned by the warfighter. It's exciting to think about over the next few years how this system is going to actually be used versus how it was envisioned to be used by the original designers.
Thanks, Commander. It's now time to get back to the mission.
RL-10 continues to look good. Chamber pressure, LOX pump discharge, fuel venturi, all within expected operating parameters. Tank pressures are good. Batteries look good. PU's controlling at nominal MR. Approximately 2 minutes left in this burn. All systems continue to look very good. Fuel tank pressure levels are increasing as expected for this point in the mission.
This is Atlas Mission Control at T plus 25 minutes 20 seconds into the flight. We're a minute or so away from the completion of the second of the Centaur main engine burns. Let's go back to Marty Malinowski for the final call-out of the morning.
And PU has been commanded to fixed angles in preparation for a MECO. And we have MECO. Engine shutdown looks good. We have 4S settling motors on. Fuel tank pressures are being vented down. Storage bottle pressures look good. Batteries are good as well.
This is Atlas Mission Control at T plus 26 minutes 39 seconds into flight. 2 of the 3 planned Centaur RL-10 engine burns have occurred, and the mission is now in an extended coast phase, with all systems continuing to operate as expected. After completing a 2-hour, 23-minute coast period, the Centaur main engine will be restarted for a short third burn, followed by a short coast period. MUOS-4 delivery on orbit is scheduled to occur at 2 hours 53 minutes. Due to the long duration of the flight, we'll now conclude our live coverage. Commander, thanks for being here.
Steve, my pleasure. So as you can see, this is another important milestone in the MUOS program. So go MUOS!
Okay. I'd like to thank Marty Malinowski for his support of today's show, and for more information on the Atlas V, please visit our website at ulalaunch.com or join the conversation on Twitter or Facebook. We'll complete our live coverage with another look at today's launch, which occurred at 6:18 a.m. Eastern Time. I'm Steve Agate, and on behalf of the entire ULA launch team, have a great day. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. RD-180 ignition and liftoff. Liftoff of the United Launch Alliance Atlas V rocket carrying the fourth Mobile User Objective System mission for the United States Navy. MUOS significantly enhances communications for U.S. forces on the move. You're now hearing the voice of Marty Malinowski providing launch vehicle ascent data. Let's listen in for mission progress.
Roll program is complete. SRB chamber.